Okay, awesome. So what we're going to do is 3.1, and what we've been doing in the unit is just functions in general. This is the only day we're going to take a focus on a certain type of function, quadratic. It's going to be really straightforward because we know how to graph functions, and that's really what it's going to be asking us to do is graph. But first of all, just looking at a parent function y equals x squared here, we need to see that we have a vertex. Now remember, vertex means high or low point, so max or min. This would be a min. Our vertex is at 0, 0. This is the parent function x squared with no shifts. Now what we can do is we can take this parent function and start shifting it around. Wouldn't that change our vertex? So let's say we went right 3 units down 2 units, and then I redrew the quadratic. Wouldn't my new vertex just be at, if I went right 3 down 2, it would look something like this, right? So my new vertex would be at 3, negative 2. So we can rewrite that in shifted form. We can take this parent function and write it in shifted form. Isn't that how functions work? Shifts left and right, shifts up and down. So that's how this one would be written. This would be x minus 3 squared minus 2, just inserting the shifts. Because we know shifting for all functions works the same. This is your shift left and right. This is your shift up and down. All right. So if I told you the vertex of our new quadratic is at 3, negative 2, could you write the equation? Yeah. And then could you go the other way? If I gave you this equation, could you graph it? Yes, right? Right 3 down 2. We could make an XY chart with our parent function, and then we could perform the transformation. All right, so here's the thing though. If it's in shifted form, it's really easy to go ahead and graph it. But if it's not in shifted form, then for example like this, is really easy to graph. Let's say, what is the vertex? You tell me. You said the shift is left 5 and down 1. Therefore, the vertex is negative 5, negative 1. So negative 5, negative 1. Now from there, this is how I would do it. Just because this is kind of the theme for the year, this is kind of really how we've been graphing. We take our parent function x squared, taking off the shifts, make an XY chart for that, plugging in negative 2, negative 1, 0, 1, and 2. Negative 2 squared is 4, negative 1 squared is 1, 0 squared 0, 1, 4. Okay, and then you said it was left 5, so when we subtract 5 from x's, down 1, so we'd subtract 1 from our y's. This is how I would finish graphing this one. So negative 2 minus 5 is negative 7. Negative 1 minus 5 is negative 6. Negative 5, negative 4, negative 3. I'm just subtracting 5 from all of them. And then subtracting 1 would be 3, 0, negative 1, 0, 3. So now look, we already know negative 5, negative 1 is our vertex. And then from there, negative 7 up 1, 2, 3 units. Negative 6 up 0 units. Negative 4, 0. Negative 3 up 3 units. And there's my shifted quadratic. Okay. So if it's in shifted form, really straightforward. Well, what if it's in standard form? What I call standard form. This is standard form like that we've seen in previous books. So if a quadratic is not in shifted form, it's a little bit harder to graph. Now here's the thing. If we find the vertex, we can then put it in its shifted form, and then graphing it will be easier. Now notice I said put it in standard form. Here's the interesting fact. This new book we're using calls standard form the shifted form. So if on the test you see them say, write this in standard form and then graph, that would mean put it in shifted form. Okay, so then that's just different wording from this book. All right, so we can find the vertex, just a reminder, if something is in non-shifted form, so such as x squared plus 2x plus 3, and we wanted to find the shifted form, we could find the vertex using this formula. So everybody write down the formula, we've seen it this year. X equals negative b over 2a is the x value of the vertex. That's how we find it. Negative b over 2a. And then to find the y value, think of how functions work. I take an x value and plug it into a function to find out the y value at x equals whatever. Does that make sense? So you'll calculate x, then you'll take and plug it back into your function to find the y value. And now once you know the new vertex, you know the shifts. So if you know the vertex, you know the shifts, and then we'll just insert it in as is. So let's go ahead and practice this one. If I said take this to standard form, remember that means shifted form. So you'll hear me say, I'm going to probably just say non-shifted form and shifted form. So you'd say, okay, I got to find the vertex of this. So I know I need to do x equals negative b. ax squared plus bx plus c. So negative b would be negative 2, wouldn't it? Over 2 times a, so over 2 times 1. Isn't that negative 2 over 2? Which is negative 1. The x value of my vertex is negative 1 comma something. So I'll take negative 1 and plug it back in, calculating. Negative 1 squared. Oh wait, did I get, yep. Negative 1 squared plus 2 times negative 1 plus 3. Isn't negative 1 squared 1? Plus negative 2, so I'll say minus 2 plus 3. 1 minus 2 is negative 1. Negative 1 plus 3 is 2. Well, if this is my vertex of this, then let's put it in vertex form or shifted form. So it'll be y equals, I'm going to put an a there. We'll talk about a in a second. So since it's left 1 and then it was shifted up 2, isn't it true that it should be x plus 1 squared? And then the up 2, the sign stays the same, plus 2. Now the a value is actually going to be really easy. All you need to do is look in front. Isn't the a value 1 here? Then it's going to stay the same. The a value is 1. 1. We'll just call that a 1. So now that I have it in shifted form, I can graph it. I can make a parent function. I can then graph it. Does that make sense, everyone? That's what this lesson is. So let's just practice that a couple more times. Make sure you're asking questions. Okay, this is how the homework asks it. It says, graph a quadratic in standard form. So right here is considered non-shifted form. So you'd say to find the shifted form, I'm going to do x equals negative b over 2a, which is positive 4, isn't it? Negative of a negative. And then over 2 times 1, so that's 4 over 2, which is 2. So my vertex is 2, comma, now to find it, we'll plug it back in. 2 squared minus 4 times 2 plus 1. So that's 4 minus 8 plus 1, negative 4 plus 1. Negative 3. Remember, we're all agreeing to participate today. All right, so now I will write it in shifted form. F of x is equal to a, and then it's x minus 2 squared minus 3. The leading coefficient was a 1, so it's a 1. And now to graph it, you'd make an x squared xy chart. Then I'm shifting it. We said right 2 down 3, so plus 2 minus 3. Here's your official xy point you would graph. Negative 2 plus 2 is 0. Negative 1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. 4 minus 3 is 1, right? 1 minus 3 is negative 2. 0 minus 3 is negative 3. 1 minus, sorry. Oh, where am I lost here? Oh, no, we're good. Negative 2, 1. So now graphing that. Over 0 up 1 unit, check. Over 1 down 2 units, check. Over 2 down 3 units, which is my vertex. Then over 3 down 2 units, over 4 up 1 unit. And there's my shifted quadratic. Questions on how to do that? Pretty straightforward, huh? Put it in vertex form and then answer the rest of the questions. Okay, so is this vertex a maximum or minimum value? It's a min, it's a low point. If it's a smiley face, which we can determine from the leading coefficient being positive or negative, since the leading coefficient is positive, it's a smile, therefore it would be a min, a low point. So we'd say it's a min. And then our x-intercepts and y-intercepts. Now everybody, x-intercepts are when y equals 0. Y-intercepts are when x equals 0. So let's do y-intercepts. Y-intercepts are the easiest problem of the whole thing. Look, plug in 0 right here. 0, 0. Won't this be the only thing that matters every time? Because if you plug in 0, it's going to not matter, besides the constant. So if I plug in 0, I get out 1. The y-intercept is going to be easy. Look, 0, 1, all good. Our x-intercepts, everybody, look, it's where it crosses the x-axis. We're not going to be able to tell from our graph unless it crosses that whole number points. So here's how we find x-intercepts. This is not part of the lesson. You should already know how to do this. Everybody listen. X-intercepts are solutions of the quadratic, the zeros. Okay, so what we do is we set our quadratic equal to 0. That's setting y equal to 0. So 0 equals x squared minus 4x plus 1. We solve by factoring, if possible, and if not, the quadratic formula. Okay, everybody, I'm not going to go over the quadratic formula. Yes?
Can we do the zeros for the shifted form?
Even so, that would come out the same. Oh, yeah, I see what you're saying. You're such a smart thinker. She is such a smart thinker. Okay, awesome. Isn't that going to be 10 times easier? Yes. Yes, I'm so glad you asked that. Guys, look, see, if you think and ask questions, sometimes the lesson goes better. So look, 0 equals x minus 2 squared minus 3. Oh, you're a genius. I just want to hug you, but I won't. Okay. Add 3. So 3 equals x minus 2 squared. Then what? Square root. Don't I need a plus or minus? Then I add 2. So I have 2 plus and minus root 3. And boom, so much easier than doing it the quadratic formula way. So now you'd say, okay, my x-intercepts are x equals 2 plus or minus root 3. And then that's fine. Good enough. Okay, great. Okay, another one where the leading coefficient is not a 1. All right, so notice the leading coefficients too. Don't worry about it for now. Just find the vertex. So you do x equals negative b over 2a, which is positive 12 over 2 times 2, which is 12 over 4, which is 3. The x value of our vertex, 3. Plugging in a 3 to find the y value. 2 times 3 squared minus 12 times 3 plus 23. Go ahead and calculate. I'm trying to remember what I get out. 5. Okay, now we know our vertex. So you'd say f of x is equal to a times x, and then it's right 3, so minus 3 squared, up 5 plus 5. Does everybody see? Now a should be the same as this a, so we just got to go down and say actually it's 2 times x minus 3 squared plus 5. That's it. It's not anything super hard. Then from there, everybody, watch what you would do. First of all, it's a smiley face again, so we know it's a min without even graphing it. Looking at this, here is what I would do. So, making your x squared, xy chart. Just a reminder, because I had people asking questions on this last hour. Negative 2 squared is 4, 1, 0, 1, 4. And then, okay, so right 3, up 5, vertical stretch of 2. Doesn't the vertical stretch affect your y values? So we got to go to our y values times by 2 first, and then after that add 5. And then right 3 will add 3 to our x's. Here are your official xy points. So negative 2 plus 3 is 1. Negative 1 plus 3 is 2, 3, 4, and 5. And then 4 times 2 is 8. 8 plus 5, 13. And then we have 1 times 2 is 2, plus 5 is 7. 0 times 2 is 0, plus 5 is 5. So then 7, 13. So everybody looking at this, you know 3, 5, I'll just start there since that's my vertex. 3 up 5.
We
Then
add a y.
yeah, see that's, so the vertical stretch or compression is always only multiplied to your y values. That's why I wanted to show this one all the way through. So the next one I won't, because I think you get the picture after that. I just wanted to remind you. So then over 4 up 7 units, and that's our quadratic. Okay, let's answer these questions. Okay, x-intercepts, do you want me to go through finding that? Set it equal to 0, so when we subtract 5 divided by 2 square root. Oh, well, first of all, is this even crossing the x-axis? So if we did solve it, we'll get i's, which will say there are no x-intercepts, so none. So that's actually a smart idea. So just look at the graph before you do it. Our y-intercepts are always when x equals 0. This should be very quick. 0, comma 23 every time, right, everyone? And we're done. Okay, how about you guys try putting this one by yourself in vertex form? I think you can graph it after that. I'm not worried about that. Putting it in vertex form is my main concern here. Okay, so what did you get in shifted form? F of x is equal to, what was your a value? 5, and then you had a x minus 3 squared, so that must mean that you discovered that this was a 3. plus 4. So you also must have discovered the vertex is at 3, 4. Okay, good. Is it a smiley face? Yes, so it's a min. Is there any x-intercepts? Think about it. Shifted right 3, up 4 units, and it's facing upward. Any x-intercepts? None. Our y-intercepts takes 2 seconds. 0, comma 49. Very good. Questions on that? You guys did awesome. Okay, don't take notes. I just want to show you, even if answers don't come out as whole numbers, and even if you have a negative in front, it all works out the same way. I don't think you need to take notes. I just want to show you all your answers are not going to come out beautifully. But that's what's so nice is it's the same thing. So you'd say to find the vertex, it's x equals negative b, so that'd be negative 1 over 2 times a. So that's negative 1 over negative 2, which is 1/2. So 1/2, comma, then I'm going to plug it in, negative of 1/2 squared plus 1/2 plus 2. Now, isn't this negative not squared? This negative is not squared, everyone. So we have a negative, and then we have 1/2 times 1/2, which is 1/4, plus 1/2 plus 2. Watch me add all those together by hand, because remember, you can't do it in your calculator. This is over 1. I need a common denominator. The common denominator is 4, correct? So I'm going to times by 2, times by 2, times by 4, times by 4. So now I have negative 1/4 plus 2/4 plus 8/4. Negative 1 plus 2 plus 8. 8, 9, 10, 9/4. So 9/4 is here. So now our shifted form will be f of x equals, what is a here? Negative 1x minus 1/2 squared, and then plus 9/4. So just because the answer doesn't come out 4 just doesn't change anything. Everybody good with that? And then from there we'd be able to go through and do all these things. Okay, cool. Alright, so if I just said to you, let's just test your abilities here. These are the last 2 examples. Find the max or min. Tell me if it's a max or min. So just tell me if it's a max or min. A min, because it's a smiley face, because our leading coefficient's positive. Okay, good. And we'd use that formula. We've just been doing 10 million times. Okay, I'm not going to do it then. This is a frowny, therefore this is, because it's negative, so this is a max, and then x equals negative b over 2a. You guys get the picture. Okay, so guys, the story problems in this unit are the easiest. She said I don't have copies. I'm going to have to see what's going on. What? Oh, freak. Yeah, I think you're right. Sorry, thanks. Okay. Okay, guys, so you guys, I'm telling you, 1050 will have story problems. This unit's the easy. Have we ever had to create a story problem? No, they've all been chug and plug, and it's no different here. So let's read this. Most cars get the best gas mileage when traveling at a certain speed. The gas mileage M for a certain speed is given by this function. What is the car's best speed to get the best gas mileage? So everybody, isn't that going to be finding like a maximum? The max is the best, isn't it? So the maximum speed for maximum gas mileage, that would be the best. So everybody, the max gas mileage, does everybody see? So first of all, when you read it though, sometimes it's asking for the x value and sometimes it's asking for the y value. You've got to read it and determine which one. So let's read. What is the car's best speed? Isn't that the x value? Isn't s x, everybody? It said, what is the car's best speed to get the best gas mileage? So it wants s. What if it said, what is the car's best gas mileage? Wouldn't we have to find s, the x value, and then plug it back in to find the y value? You guys see the difference? So this one only needs the x value. You'd say x equals negative b, which is negative 3 over 2 times a, which a is negative 1 over 28. Watch the math behind this, because I still have people having a hard time with fractions, watching very carefully. On top, to make my life easier, I'm going to write this as negative 3 divided by 1, since that is the same thing, to help me when flipping, to flip correctly. Now, right here, multiplying straight across, I'm technically doing this. 2 over 1 times negative 1 over 28. Does everybody see? We multiply fractions straight across. That means 2 times negative 1 is negative 2, divided by 1 times 28 is 28. Now, dividing fractions, easy as pie, flip the second and multiply, so we have 28 on top and negative 2 on bottom. So you'll do negative 3 times 28 divided by negative 2. So the s came out to be
42.
So 42 Miles per hour is when you're going to get the best gas mileage. So once again, in the story problem, if it would have said, what is the best gas mileage? You'd say, okay, now I need to take and plug in 42. Does everybody see? You got to read the story problem because that would be such a shame to not get it right on the test. But this one just said, what is the best speed to get the best gas mileage? 42 mph. So what if, guys, what if I gave you another story problem that said, here's an equation for cost. Find the minimum cost of the revenue, whatever. What would you do? Find the min. If I said, what's the minimum cost, you would find the min. Does everybody see? And that would be the y value. So those story problems are just going to be find the max or min. What if it said find the maximum amount of profit? Instead, you'd find the max. Do you guys see what I'm saying, though? It's all in just the story problem, find max or min, which is just finding the vertex. Okay, that is the end of the lesson. So, you have now an hour to work on homework. Make sure you're working on it so you can ask me for help if you need it.